In the first example, we see an extremely simple pattern. The numbers simply go in order, starting from 2. Therefore, the missing two numbers following 7 are 8 and 9. In the second example, the pattern is the same, only the numbers are arranged in descending order. Therefore, a 5 should be followed by a 4 and a 4 should be followed by a 3. The third example will also not be difficult for us to solve if we pay attention to the fact that the numbers follow each other, successively increasing by 5. What's next? 30 plus 5 is 35, 35 plus 5 is 40. The fourth example has a similar sequence. Numbers starting from 6 increase by 3. 21 plus 3 is 24. 24 plus 3 is 27. Fifth task. According to the condition, we are again given 6 numbers. What can we say? These 6 numbers can be divided into 3 groups of 2 numbers each. The numbers within the group are equal to each other, and from group to group they decrease by 2. We boldly conclude that in the fourth group, the numbers of which we must determine, 4 minus 2 is 2, so the pair of missing numbers is 2 and 2. Task number 6. Here the pattern is also very simple. All numbers increase by 4. This means that the pair of missing numbers is 27 and 31. In task number 7, we see the following sequence of numbers. We can also divide this series into 3 groups of 2 numbers. The first numbers in each group are successively decreased by 2, while the second number remains unchanged. This means that in the fourth group, the first number should be 2 less than 5. This is 3, and the second number will remain 1. When solving the 8th exercise, we use the same method. Therefore, we conclude that the fourth group consists of the numbers 16 and 17. In the 9th example, we do the same. We see that the numbers in each group are the same and decrease by 4, so the last 2 numbers are also the same and equal to 13. 10th task. All numbers are sequentially doubled, which is an example of a geometric progression. What numbers are missing? 64 and 128. We have already solved half of the problems. Let's move on to number 11. What is the pattern here? The numbers are consistently decreasing, but the magnitude of the decrease alternates from number to number. This means that the next decrease occurs by 2. 8 minus 2 is 6 and 6 minus 3 is 3. This is the solution. Next, example number 12. The difference between the first and second is plus 2. Between the second and third is minus 1. Then again plus 2, again minus 1. And then the required numbers are 15 and 17. In the 13th example, the picture is similar. First minus 4, then plus 3, minus 4, plus 3, and so on. Example number 14. Numbers are successively decreased by different amounts, minus 1, minus 2. The required numbers are 16 and 15. In the 15th example, everything as we can see is divisible by 2. Therefore, the answer here is 1/4 and 1/8. In example number 16, the numbers increase by an amount that itself consistently increases from time to time in arithmetic progression. Plus 1, plus 2, 3, 4, 5, then add 6 and 7, and we get 24 and 31. We see something similar in task number 17. Plus 3 plus 5 plus 7, 9, 11, then 13 and 15. The answer is 49 and 64. Example number 18 is very interesting. The magnitude of the change in numbers is constantly increasing in absolute value in an arithmetic progression, but the sign alternates, sometimes minus, sometimes plus. Then the numbers we are looking for are 19 minus 6, 12, and 12 plus 7 equals 19. Task number 19. Are the numbers apparently decreasing? What is the pattern? Minus 3, minus 2, minus 1, and then again minus 3, again minus 2. It is logical to continue this series like this. 10 minus 1, 9, 9 minus 3, 6. And finally, the last building, number 20. The pattern here is perhaps the most interesting. First, there is a doubling. Then we add 2. Double again and again plus 2. Double 44. What's next? That's right, 44 plus 2 and 46 times 2 is 92. Thanks everyone for watching. If you liked the video, don't forget to send it to your friends.